Welcome to today's webinar. We're going to talk about Keystone's KeyPrint 3D innovations, and then also navigating all the dental workflows that Keystone works very hard to continue updating for all of you. So, a little bit about myself. As mentioned previously, I've been at Keystone since 2019. I've been our 3D printing engineer and overseeing our KeyPrint validation program here at Keystone. It's been a very fun 4 years and always enjoy being able to jump on a webinar or go to a speaking session with the Zahn team. So very happy to be here today with them. So a quick little recap just from the past 6 to 8 months of what I've been up to. This past March was my first time being able to go to IDS 2023 in Cologne, Germany. It was a great time, as you could see here. Keystone, we were able to represent a lot of our printer partners. I got to see a lot of our partners, customers, and got to talk a lot about 3D printing, which is one of the best things I like to do every day. So that's what we're going to do today for the next 45 minutes. You're going to hear a lot about 3D printing from me, everything from Keystone's perspective. And we see a lot of things throughout all the different workflows, the different printers. So we have a really cool point of view on the digital workflow. Another quick thing as well, over the last summer, been doing a lot of camping, a lot of hiking, getting into yoga, and then a quick shout out to the best dog in the world right there. That's Honey. Anyways, today's objectives, what we're going to be doing on this webinar, we're going to talk about what the KeyPrint compatible validation program is and what do we do when we say that. We're going to talk about all of our KeyPrint resins and what's new coming up in the near pipeline. We're going to talk about the current 3D printing printer landscape, all the different printers that we work with here at Keystone. We're going to go into a little bit of troubleshooting printing failures and kind of a good steps for you to kind of go into troubleshooting any failures you receive here in your lab or your clinic. And then also, after the printing is done, there's a lot of things that are going on with the post-wash and the post-cure. So we're going to talk about that. We're going to go through some of those tips, and I'm going to give you some advice so that you could provide the best medical devices and 3D printed products to your customers. So, Keystone Industries, who are we? I know Keystone, over the last 4 years, KeyPrint has been our growing brand. But here at Keystone, we have a ton of different products from the acrylics, from the Proform line, different polishing compounds, and also different dental packaging options. So as you can see, Keystone, we've been in the dental market for almost 100 years with decades of experience with manufacturing different photopolymers and acrylics. As you could see and already mentioned, we have over 4,000 different dental products, from operations, lab, preventative care, and digital products, which is what we're going to talk about today. So we have 2 manufacturing sites, one in Pennsylvania and one in New Jersey. Both are FDA registered as ISO 13485 for medical device manufacturing. And we have sales teams across both the United States and over in Europe and Asia as well. So, we're, as a global company, we're looking forward to being able to help share as many of these products that can help you in your lab and your clinic. So one of the biggest things that has allowed us to help progress with these products into all of these different markets is the compliance side of things. We have a nice regulatory team that's been helping us get all of our KeyPrint products and all of our other products all into different regions across the globe. And when it comes to our validations particularly, we heavily rely on our regulatory team to help make sure that our testing and everything we do with our KeyPrint workflows are tested to the according to all regulatory bodies. All right, so now we're going to start getting into some more technical things, more KeyPrint things. So let's talk about what Keystone does when we talk about this KeyPrint validation program. So how do we help you? So we all know that the validation, the process from printing anything goes from using a material to any 3D printer, from a cleaning process to a post-cure process. So what we do here at Keystone is we are controlling this entire process and workflow and optimizing every aspect, just so that you, the end user who is 3D printing these devices, should be able to rely on us for all of the parameters and IFUs. So it's an easy process for you. So one of the first things that we're doing with all of our KeyPrint materials and across all of the 3D printers that we're validated with is that we're first working with the 3D company to develop accurate printing parameters for that workflow. Along with those printing parameters, once they're developed, we also want to make sure they're fully optimized, A, for speed, but B, we also want to make sure that we have full build stability. If you're going to print one splint or you're going to print 20 splints at a time, we want to make sure that our settings that we provide gives you that capability. So once parameters are developed and the material and printing stage is completed, we now focus on the overall digital workflow, taking that 3D printed device and handing it down to that patient. We walk through that entire washing protocol, curing protocol, and we try to provide as many validated workflows for you to be able to choose from. So with that said, we do have a Keystone IFU for our post-wash using isopropyl alcohol. We'll talk about that later down in a few slides. But the biggest thing to take away from this slide is that with a material that has now been fully optimized with printing settings into a printer, we're now going through and identifying the proper washing and curing protocols to make sure that your end device and your workflow has no issues. And to do that, we do mechanical ISO and ASTM testing. We go through extraction testing, and then we also do biocompatibility. So every medical device validation that we do put on our website has been tested through these 3 tests, and we can confidently say that you are safe to use this workflow. So this is a really big deal because this now allows us to provide you proper parameters around which pieces of equipment, which materials you wanted to use in your lab, but also gives you and gives the doctors and then gives the patients as much confidence as possible to make sure the patient is fully complying with the device that they're using. And then also as a lab, you know, if you're running into printing issues, printing failures, workflow issues, end device issues, you know, you can always come back to Keystone for some technical support. And we've been able to help rectify a lot of these issues with certain labs because we go through the testing of the entire workflow. So when it comes to troubleshooting issues, this is exactly the process we go about that. We walk through the individual validation process as we see here on this slide. So with all of that said, as a team here at Keystone, we've been able to really help scale up our efficiency with our validation program. And also a lot of new printers are coming out on the market the last few years. So we've been able to help get our validation program from the 5 printers back in 2019 to now working with over 40 different printer OEMs. And this document that you're seeing here on this page, you can easily find this at our website as well. And I'll show you that at the end of this webinar. So we're going to go through a little bit of each of the resins, and then we're going to talk a little bit more into the some technical information behind each of the resins. So I think everyone at this point knows what Keystone Soft and Keystone Hard are. It's two of Keystone's top performing resins. And the biggest thing that has kind of allowed Keystone Soft to take off as a top leading splint product is that its soft capabilities once acclimated to the mouth's temperature. So printing Keystone Soft, which is validated across 40 different 3D printers. So soft and hard are both validated among 40 plus different printers. But the best thing about Keystone Soft as well is the printing process is pretty easy. Everything is pretty nice and controlled. Washing is really nice. And then when it comes to actually inserting the device into the patient, putting the device in some warm water helps with compliance with insertion. So one of the best things about Keystone Soft is that it's durable and it's firm when at room temperature. But then once it softens up in the mouth, you wear it for 10, 15 minutes and it starts to soften up. You get better customer compliance in terms of just how it feels across the gums, how's it feel at night. And then before you know it, Keystone Soft is well loved across many patients. Keystone Hard, very similar to Keystone Soft, but Keystone Hard is just your traditional hard splint. Both materials are indicated for splints, night guards, and Keystone Hard is also indicated for retainers. And Keystone Soft is also approved for both bleaching trays and sleep apnea devices. One of the biggest things I want to make sure is just communicated through this webinar with each of our materials is kind of recommendations on both supports and nesting. One of the biggest things we see when it comes with troubleshooting with customers is how to properly nest and support your splints. So as you can see here, we're going to walk through each of the resins, but you'll see right in the middle of the screen, you'll see our recommendations both with support settings, the contact width and the support width, and also nesting angles for each of the materials. And if you haven't already realized, with one bottle of Keystone Soft or Keystone Hard, there's a ton of value from a lab's point of view. So with the assumption of about 12 to 15% of waste, which the more 3D savvy you become, the more you're able to optimize on limiting your waste factor. So your profit per bottle can only go much, much higher the more efficient you become. But this is a good look at just how valuable one bottle of Keystone Soft or Hard can do for your lab. Also, if you didn't know already, Keystone Hard and Keystone Soft is now available in clear versions. So now we have 4 different splint resins, Keystone Soft both in tinted and clear, and then Keystone Hard both tinted and clear. And you could also go to our website to find more validation information on which printers are validated with both. Now, with that said, we will go into Asiga's Ultra Gloss, which I know is one of our poll questions. So the Asiga Ultra Gloss is one of the newest innovations from the Asiga team. And the Asiga has worked really well with Keystone when they were developing this product, as everyone, a lot of people are using Keystone's resins and Keystone Soft, particularly with this Ultra Gloss. So when it came to developing this product, the Asiga team definitely leveraged us a lot to make sure that it worked very well with Keystone Soft, and it does. So one of the best things about what this Ultra Gloss is all it is a brand new tray. So if you already have the Asiga printers, whether it's the Asiga Max or the Asiga Pro 4K, this is just a new resin tray that you would buy from your dealer. So step 1, buy the resin tray. Perfect. So step 2, now we're going to talk into what's different from a normal printing normal splints versus printing splints with the Ultra Gloss. So the whole point of the Ultra Gloss is, as you could see in step 4, is to be able to print out full splints that are fully clear and digitally polished without needing to then go do the physical manual polishing at the end. So as you could see in that step 4, coming right off the printer, these splints are now able to be fully clear and look as if they were already polished. And this is a huge game changer when it comes to labs that are producing splints at a high volume. So when it comes to step 2, on preparing proper nesting and supports with Keystone Soft Clear or tinted, there's 4 different options that the Asiga team recommends. And as you can see, I have photos of those options below. So Asiga recommends that you print all of your splints vertically. As you can see, both the posteriors are down on the build plate. And as you could see, everything's being printed pretty vertically, anywhere between that 80 and 90 degrees recommended by the Asiga team. The goal of Ultra Gloss is to print your splints with minimal to no supports whatsoever. So that's why you could see that printing these vertically, you can either have them printed vertically on supports, custom supports, or you can have a planar cut where you're bringing the splint into the build plate and it will be attached to the build plate directly from the splint. Now, what this does is this eliminates the post-processing afterwards. So once you go from printing to washing to post-cure, everything coming out at the end of that should come out looking fully polished. And that's where there's a lot of value here with the Ultra Gloss. So once you're able to test out and you finalize a good nesting and support strategy, the next thing you want to do is also confirm your proper settings. When it comes to the Ultra Gloss and when it comes to Asiga Composer, you want to just make sure that you're selecting the proper build tray settings. So you can see that I have there material setting, layer height, and you want to change your build tray setting to Ultra Gloss. So these are very important aspects. And then number 4, save time and save money. So all of this information here can be found from Asiga's support, Ultra Gloss support document, which can also just be found on their website as well. Reach out if you have any questions on where to find that information.
So, Ben, I'm so sorry that it took me a while to get the poll questions up, a little technical difficulties, but just to let you know, the poll number 1 was launched and I did love the results. It seems that none of our attendees have tried the new Ultra Gloss resin. So, just wanted to let you know that. Thank you.
Awesome. Yeah, thank you very much. So I'm glad that I actually went in and explained that a little further. So if you haven't used the Ultra Gloss, again, this is just a separate tray that you would buy, similar to that universal tray that you normally would buy if you own an Asiga. And again, this is for the Asiga printer. So the assumption here is that you have the Asiga Max or the Asiga Pro 4K. But again, as you can see in number 4, the splints coming right off the printer and being post-cured are coming out looking fully polished. So if you're spending a lot of time in your lab doing polishing on the back end, it might be wise to take a look at that value add on being able to eliminate polishing totally. All right. So Key Guide. So Key Guide's our surgical guide resin here at Keystone. It is actually one of the best surgical guide resins on the market from what, non-biased here, but from a lot of my conversations with labs as well, this is one of the strongest surgical guide resins that are on the market, assuming that you're working with a validated workflow, of course. That's a huge assumption. We need to make sure that we have that locked in from here on out. So Key Guide, we have validated among 30 or so different printers so far. It's probably one of the most reliable resins you can work with. If you printed with Key Guide, it is very crisp, very clean, and typically you shouldn't have many issues printing with this resin. Key Guide is fully autoclavable. We have guidance documents of autoclave parameters and an IFU, all found on our website under the Key Guide section. And then also with Key Guide, as you can see right here, is I do have recommendations on nesting and supports. And with surgical guides, there are a million of different types of designs that you can have. I think the best thing to keep in mind is that you want to make sure the sleeves are as clean and as accurate as possible. So anything that's a full arch or a quadrant, printing from a flat to about a 45-degree angle on supports usually is the most optimal. You get a little bit more challenging when you are printing a full palatable surgical guide, to which you want to kind of just make sure that you're viewing your slices and where your supports are to make sure that all the sleeve holes are properly printing, no supports being incorporated inside of those. You want to have those being accurate as possible. So Key Tray. So our Key Tray resin, as you can see here, looks really nice coming off the printer. Is for our custom impression trays. We have currently Key Tray validated among 23 different printers and growing. And with Key Tray, as you can see, pairs perfectly well with other Keystone products that we sell here to help you with the impression process. Key Tray, similar to our Key Guide, is a Class 1 medical device, and Key Tray has been really good to work with. I think one of the biggest keys with working with Key Tray is just proper support settings, as you can see. So we do recommend having a minimum contact with a 0.65 millimeters. The biggest thing is, and also is just the nesting. As you can see, impression trays can be typically big to print. So there are multiple ways that we recommend printing the trays, usually printing with the handle directly on the bill plate and printing at 90 degrees has been usually the most accurate and most stable print. But this is whereas the end user in the lab, you have all opportunities to print in many different orientations. And as you can see here, you can print on the bottom right of the screen. I have a photo that where you can print your impression trays fully flat, but you can also, we recommend printing them at from a 35 to 90 degree angle. So these are just all different types of suggestions to where you can have a clean print. But for the most part, we have seen mainly issues with just supports being able to not have proper contact widths. So when you have an entire tray, impression tray printing on very thin supports, a lot of that peel force would rip that tray right off the supports. And that's where you begin to have a failure. So that's just something to keep in the back of your mind. Okay. So Keydent was a resin we launched within the last year and a half. So Keydent is indicated for denture trions. This is a class 1 medical device, so it is short-term use, no more than 24 hours in the mouth. That is recommended per the indication of this product. But also Keydent Trion is available in 3 different shades, A1, B1, BL4. What I like most about Keydent Trion is really the exceptional surface quality and how easy it is to be polished, be characterized, or both. And you could see here going through a workflow of just that being printed, characterized, and used on a patient for this process. So one thing to keep in mind with trions, typically whether you're printing an implant style trion or a full monolithic, you could see our recommendations on how to properly print them as well. One of the biggest things you want to just make sure is that you retain the accuracy within that intaglio region for the customer for that fitting process. And then other than that, Keydent Trion is validated currently on 16 different 3D printers and growing. So be sure to check out our website for our latest validations with the Trion product. Alrighty, so Keyortho IBT is our indirect bonding tray material. May not be a well-known material in the lab space. This is really typically in the orthodontic space. We currently have IBT on 20 or so printers, and that is also a validation that we're growing into more and more printers as we go into the new year. The great thing about IBT trays is that you don't need supports. Printing them is practically the easiest thing you can do. Just directly flat on the bill plate will do the job. IBTs typically, because how small the products are, they're very quick to print. So the entire bonding process with this IBT can be done in chair side, which is fantastic. Another cool couple things about the IBT, it is one of our class 1 devices as well, so it is fully biocompatible. It is a flexible IBT tray, and then it's also not sticky. So being able to release in application is actually really good. Alrighty, so we just went through most of all of our medical device products. So now let's jump right into our model materials. So as you could see, Keystone, we have currently 4 different model materials. To give you a little bit of history on that, we first launched Key Model and Key Ortho Model as our original model materials back in the 2018-2019 area. Key Model was indicated mainly for restorative, crown and bridge use cases and modeling for that. Ortho Model was positioned for aligner models. Now, as of recently, over the last 2 years, Keystone has launched a re-engineered and much better model material that's now available in 2 different pigments, both ivory and light gray. So that's our new Key Model Ultra resin, which has become the #1 selling resin here at Keystone. and you can see for just a liter at $82, and validated, across 20 or so different 3D printers. It does provide a lot of opportunity for labs to take advantage of a really good model material. And what's great about all of these different model materials is just that, Keystone, we spend a lot of time working with all of these models on all of these different printers. So we're able to help provide as much technical support as possible if your lab is having issues printing with our model materials. And that's something you can reach out anytime to our customer service, and we'll be able to be connected to our technical team and help you rectify any issues in the lab. And then last thing with these models is really the printing side. And, mostly models can be printed directly on the build plate without a problem. Now, sometimes you're going to run into some issues where if you're printing a full, dense, solid print, sometimes you would recommend printing some of your models on supports. If your models are fully hollow without any drain holes, printing them on supports is definitely necessary. One of the biggest things you really want to just keep in mind when printing not only models, but really anything, is just liquid resin being trapped. So if you have a hollow model being printed directly to that build plate, there's going to be a point where that model is closed in, 3D printed, and now we have a bunch of liquid resin trapped inside. And this is where you're going to start having some printing issues, which can then lead to failures. So Key Mask is our gingiva mask product, very easy to print. Typically always would print on supports unless you do have a flat surface. And yeah, for $187, you get a half liter of our Key Mask. And we do have this validated among 22 different 3D printers as well. Key Mask is easy to trim, very firm, and is a really good product to handle with. And our Key Cast resin. So here's our Key Cast, indicated for different restorative investment casting products within the lab. As you could see here, supporting Key Cast can be highly challenging. Anything with copings or crowns can be easily supported on the cusps. But when it comes to a full RPD product, as you can see here, we do recommend between a 35-degree and a 90-degree angled. What's important is making sure that every part of this cast is able to be printed with as less supports as possible, just so that post-processing is minimalized. So any more information within the Key Cast product itself can also be just found on our website. So Key Guard. So Key Guard may seem brand new to some of you watching here. So Key Guard is our newest resin that we are launching right now within the next few months before the end of the year. So we are going to be coming to market with Key Guard both in white and black. And then following, we're going to be having some additional colors behind. So we're going to have red, purple, green afterwards. Key Guard is going to be a really, really great product to have. Everything that we've been working on so far in our validations are pointing to a really, really cool sports guard product. The Key Guard material itself is pretty firm and perfect when printing. There's really very minimal concerns. And this is going to be the dental market's just first widely validated sports guard material. And that's just very exciting to be able to start seeing now what the labs and customers can do with now custom sports guards. So Key Splint Pink, what is this? So Keystone is working with Zahn and also working with Nowak to provide a pink Key Splint version of our Key Splint soft and hard products. So what we're doing is Keystone and their partners are going to be donating portions of the proceeds to the Connie Dwyer Breast Cancer Foundation. So if you're interested in a pink version of Key Splint Soft and Key Splint Hard, definitely reach out to your Zahn rep or reach out to Keystone Industries, and we can let you know how to find a bottle for yourself. very excited. I'm really excited to see how this is in the market. And if your printers are validated with KeySplint soft and hard tinted, then you're validated with KeySplint soft and hard pink. So that's what also is fantastic about this. Alrighty. So going into our second poll question as well. I'm just kind of going to get started into the slide. So one of the best things that we've seen as the market has been shifting over the last few years is the amount of labs that are having more varieties of different 3D printers in their lab. And as you could see here is 53% of dental labs with 3D printers have more than one in their lab. So my question to you would be, how many different variety of printers do you have in your lab? And that is the second poll question you'll be answering. So to continue on that as well, as you could see, the large labs have almost 3 times as many 3D printers compared to both medium and small labs. So what does that tell me? So that tells me that, you know, larger labs are really looking into different printers for specific uses, whether that is different material uses, whether that's specific application uses. And that's really important when trying to even figure out what's the next printer you should get. Or if you don't have a printer yet, what's my first printer? And we'll get into that question because that's asked to me a lot. And, you know, when someone does come to me and ask what printer I recommend, that's not an answer I can just give. So the next 4 slides will actually show you what my answer is, which is redirecting the question to you, is what's most important to you when it comes to buying a 3D printer for your lab.
Okay. I'll just know what the results are so you know, like, about the attendees and what their answer is for this, because it's 45% do not have a printer at this time, 9% have 1, 18% have 2, and 27% have 3 or more. So that's pretty good numbers, so at least you know.
Perfect. Yeah, that is very perfect with the information that we have. So that's perfect. Half of you are not even printing yet. So the next 4 slides is really directed to you in terms of how do I even identify what printer is best for your lab. So we'll walk through that. And then those who, you know, have 3 or plus different printers, which is a quarter of you, I'm always interested in knowing what printers and why, because, you know, that's going to allow everyone to help continue growing the market. But back on track. We talked about all of the resins that we've worked with and all of our Keystone KeyPrint resins, our fantastic resins. I've mentioned, hey, this resin is validated with 20 printers, 30 printers. All right, well, here's an opportunity to see, okay, which printers is Keystone validated with? So as you can see here, this is your slide to show all of the different printer partnerships that Keystone is happily with. We love working with all of our 3D partners because at the end of the day, we're giving you the option and enabling you to be able to choose what you want. Which materials do you want to use in your lab? Which printers do you like? What workflows works best for you? And that's what we're about to get started talking about. All right. So going back from this last slide, what I'm doing is for the next few slides, I have a couple different graphs on the board that shows all the different printers we work with and Keystone's point of view on the different important key factors about each of the printer companies and really what you should look for when trying to invest into the digital workflow. So this slide right here shows all of the different printers that Keystone works with. And where does Keystone throw these printers on a map when it comes to discussing reliability versus throughput? And what's important is to understand is that this information is coming from, you know, us, our point of view, working with these partners, working with customers, talking with customers, and figuring out where do these lie on this map and what's actually important for the customers. So when we're talking about throughput, you know, we're really talking about how much can I actually print in one job? How much can I print in a day? You know, so this is going to be really talking about the size of the printer or even the speed. How much am I able to put through this printer? And then reliability. You're going to want to throw a full print on overnight, and be able to come in the next morning and not have concerns that you have now a full build of failures that you have to now identify. So reliability is really important as well. So I have reliability versus throughput, as you could see here. Companies, as you could see, like Carbon, Hager's, Rapid Shape, and Asiga, Desktop Health, they have large format printers. There's your throughput. They have very highly technical software for reliability. They have a great technical service. So as you could see here, this middle patch of different companies, to me, I kind of put them in the exact same group. I just need to spread them out a little bit so you can see all those different companies. But for the most part, most of these printers are putting out the pretty similar throughput. And then you're going to have some of those other printers, printer models that are just larger formatting, made for high volume printing. And that's really the difference here between that throughput and reliability, is which printer companies are focusing on high volume. If you have a large lab, that's you. Or how many of these companies are not focused more in high volume? You may not need high volume. So this is where what works best for you. This one's material availability and technical support. This is probably the most important slide out of the few here. One of the biggest things you need to make sure before you invest in a 3D printer, and again, 47% of you don't, or 45% of you don't have a 3D printer yet. So what's most important to you? Material availability, technical support. This is very important. Both of these are very important. If you have a lab where you're going to be 3D printing 4 or 5 different types of applications, are you new into printing? So do you know what resins you want to print with? You already may have specific resins you want to print with. Hey, I want to have a printer that has Keystone soft validated. Or, hey, I want to work with Key Model Ultra. What printers are validated with that? So it's very important to understand which printer companies on the dental market are opened up for all different third-party materials. For example, Asiga. Asiga is one of the most open-sourced printer in the dental market, working with 500 plus different materials. So that's a company that has all these different 3D printing resins from third-party companies on their platform. And then there's also companies that select and choose specifically what resin they want to have as their model material, what resin they want to have as their splint material, denture base, etc. So that's what that material availability is here. And you should be able to go on each of these websites as well to kind of see what materials are available as well in their printers. And then technical support and education. Are you brand new to 3D printing? The 45% of you that don't have a printer, do you want to spend a lot of time with your technicians, learning and jumping over that learning curve, which is very small, by the way, of just 3D printing? Or do you want to be able to have a company, a 3D printing company, who you can then rely on for education, for support, for training, so that once you get this printer in your lab, you're good and you're running? That's very important. You'll see more on the clinical side. You'll see doctors try to learn themselves, and then you'll see some doctors or some labs who are completely just, hey, come train me, get us where we need to be, and then they're good with their printing. So that's very important to you, and it's something that needs to be definitely needs to be something that you review to figure out what works best for you. And then lastly, customer segment. So this is also a very important slide in terms of just where these companies are focused on. So as you can see here, I have all of these printers kind of separated into the different segments that they focus on. Now, you'll see that most of these companies are really in both labs, both in a clinical space. But that's not really what I'm focused on. At the end of the day, who is the clinical 3D companies in the world, and who are the high volume lab 3D companies in the world, and where's that mid to high company? Where are those companies at, and where do you want to be? All right. So if you want to have a printer, you want to make sure that you have this printer that's working well and can be upgraded down the road. So you want to think in advance, and you want to make sure that you're aligning your strategy, your printer that you're bringing into the lab with with the company themselves. And if you're a large lab, maybe you shouldn't look at a desktop printer. If you're a large lab with high volume, you want to look at one of those printers that are going to provide you that high volume throughput. All right, so we talked a lot about the resins, we talked a lot about the printers, and we haven't talked much about post-cure. And to be quite honest, this is the most important part of the workflow. So we can develop the most accurate settings on any printer with any KeyPrint resin. We can wash it with the proper IFU wash. But if you go to a random curing unit, put a random curing time that hasn't been validated by the Keystone technical team, now you're still giving your customer, the patient, a undercured or non-validated, non-compliant device. And you can still have issues. And this is what those issues could look like. So this is a cytotoxic event. So again, going through our validation protocol, and what we do here at Keystone is for our medical device validations, we are finalizing that with a biocompatible cytotox test. We want to make sure that the post-cure settings that you're providing for that device is going to properly cure all of your devices. And if that's not the case, if you go through and produce a dental device that hasn't been validated through a proper curing unit, this is exactly what could happen, that cytotoxic event. So these are the 4 primary factors that impact post-cure, and then we'll also talk about the different post-cure units themselves. Wavelength is one of the most important aspects. For optimal post-curing units, you will see that it's more of a broad spectrum. So one of the biggest misconceptions in this 3D realm at the moment is that 3D resins can't be post-cured at a 365 nanometer wavelength post-cure unit. And that's not necessarily just the case. When it comes to printing in the printers, our KeyPrint resins are optimized for 385 to 405 3D printer wavelength, which most, if not all, printers on the market are between the 385 and 405 nanometer wavelength range. Now, when it comes to post-curing, broad spectrum post-curing is what's optimal in order to be able to fully cure every aspect of the splint. So that's just something to keep in mind. That's where like auto flash has become more of a dental standard and produces very reliable, consistent results. And the reason is that it's a flash bulb and it's a broad spectrum flash bulb. So that is also one of the reasons why you are getting consistent results every time you're using that unit. Time, temperature. So time is the length of time that we're exposing the part to this UV light in this environment. Temperature, we've seen that inducing some heat has enabled some resins to bond easier on a molecular level when it comes to post-curing. So when we come to validations, we are looking into inducing heat versus not inducing heat and seeing what's more optimal for that resin. And then also the luminous flux, which is just the intensity, how strong the curing unit is. You're going to see post-curing units that are on our website that are validated under 10 minutes. And then you're going to see some that are validated at 60 minutes. And that's because these 4 different factors are different among all these different OEMs for post-cure units. So when we do our validation work, we're going into the details of each of these post-curing units, or we're really trying to optimize post-cure settings for that workflow. We're talking a lot about workflows. Awesome. So a quick little glance on the post-cure side. I kind of did a similar thing with the printers where you could see the price difference versus throughput of most of the different post-cure units that we work with here at Keystone. And again, all of these post-cure units as well can be found across our website with which printer companies we validated them with. And as you can see on the top right, with the most throughput, probably the most cost is where you're looking at. You can see the Dreve PCU90, the Nexa X-Cure. You can kind of see in the middle of the page where the auto flash lies. So this is a good kind of sense of what's the best curing units out there, for throughput, how can I cure more at one time, and then also price. My recommendation is that you surely want to invest into the post-cure unit. As at this point, I think it's very obvious that the post-cure side is one of the most important aspects of this workflow to provide a validated, medical device at the end of the day. So the post-curing, making sure that you have a good post-cure unit with your workflow is very, very critical. All right. So we'll go into some different misconceptions, some concerns, and this is where we'll give some tips and advice to finish out the webinar. And this is also the third poll question in terms of how to troubleshoot printing failures. Now, I can probably assume half of you, at least half of you, probably have never troubleshooted printing failures, since 45% of you don't have a printer yet. So again, you're here at the perfect time to understand a little bit more of the printing side of things, how to troubleshoot a printing failure, and that's what we'll go into. So the biggest thing you want to do when you go into troubleshooting printing failures is you first want to inspect your print. Sometimes it's easy to think, all right, I have a printing failure, let me reprint, let me remove it, let me send another one, get that going. You don't want to do that necessarily right away. There can be many different reasons why your print failed, and this is where you want to take these steps. So first, inspect the print. Let's see where it's failing. Is the entire print failing off the build plate, or are you having splints failing off the supports, or are you having failures mid-splint? As you could see here on that top left, part of that posterior has failed off, and you could see in this middle splint as well, it kind of just had a shear failure mid-print. Second thing you want to do is filter your resin. Anytime you have a print failure, always filter your resin through a filter. This is a good idea as well to be able to have you check the resin and then check the tray itself. One of the biggest things is, you can have a print failure, and have something in the resin tray from a previous print. Most printers should be able to tell you if there's something in the vat that shouldn't be, but not all printers have that capability. So let's avoid that by just filtering out the resin, making sure there are no debris or failed parts in that resin vat. And then also, super important, checking the slices from the CAM software. So if you're using an Asiga, you would have Asiga Composer. You have the ability, after you have nested your splints, your guards, your models, whatever you're printing, once they're nested and you have your supports, most printers, that software should allow you to view all of your slices. And that's a very, very important, because you want to make sure that all portions of that splint or whatever device you're printing is supported in some way. As you can see here, this is an example where this splint is fully printing, and then you have this one-off red spot right here, and that is a layer that's going to start printing separately from the build. So we call these little islands. So you want to avoid islands, and that's where you would want to make sure you add supports to where these islands are going to start printing, so that by the time that island meets up with the splint, it's going to be a monolithic print, and there's going to be no failures. So checking the slices is very important to avoid that.
So we do have the results if you want to hear them, Ben.
Sure.
It looks like it's pretty split, like 38% are either not confident at all or fairly confident, and 13% are either slightly confident or somewhat confident, but no one is completely confident. So thank you so much for these tips.
Sounds good. And that is the point of today, is to build that confidence. So thank you very much. Yeah, so this is a perfect couple slides to take some notes, maybe take some screenshots as you're going through your printing journey yourself. And then again, Keystone is here to help with some any technical support that we can. So what we're going to do is kind of go into some typical splint and typical model failures that we've seen, again, working with all of these printers and resins across the last 4 to 5 years. we come across almost every failure you can think of, and that is our job as a technical team, is to try to rectify that before you get to there. But there's many ways that failures can happen, and the more 3D tech savvy you become, the more you're going to test limits. And that's just something that we understand in 3D printing. Limits are going to be tested, and there's going to be limits that you shouldn't test, and that's what we'll discuss. So what happened here is that, as you could see in this top left, there was 5 very thick splints that were printed vertically. And typically printing vertical on splints is not an issue, but this is where I said testing limits can have a trade-off. So there was 5 splints printed vertically, highly dense. As you can see, they were printed so close to each other, highly supported on the bottom. So you have a lot of resin being cured in one small area. You got to keep that in mind. The design from these splints, the anterior, that facial side is about 5 to 8 millimeters thick. So there's a ramp on the anterior that's typically uncommon with splints. This specific lab was producing these splints and had to custom design for it. So that is a concern right off the gate, was how thick the splint was on the interior. And then, as you could see here, what's actually the issue here? The issue was that the customer was receiving some partially cured resin in the anterior intaglio region. So everything was printed, washed, cured properly. We confirmed all of that. And then after everything was cured, there was like partially cured resin where you couldn't scrape it out. It was cured enough to be able to stay in that in the intaglio region. So that was a big concern that changes the accuracy of that fit. Another thing we saw was that, so that was the biggest issue. Sorry. So that's the biggest issue with this product here, was that they were getting a lot of cured resin. So we were taking a look at different options to resolve this, and we saw 2 things. First, we mentioned how, printing vertically is one of those limits that shouldn't be reached. So it really depends on your design. Printing vertically should work very fine with your splints. And in fact, most labs are starting to produce vertical splints because it helps minimize post-processing, and it also increases the throughput in a given print. One of the issues, though, is if you have a completely vertical print, sometimes the wall overhangs within the intaglio region exceeds the overhangs that we would recommend to have something self-supported. So as you could see here in this intaglio region, this is the orientation that everything was being printed in. So there's this very, very steep internal wall that we had noticed that was not supported whatsoever. We also noticed that because there's such a thick anterior ramp here, you see a lot of this red. This red is the slice that's being cured, and then you see this open pocket. So this is liquid resin that's going to be sitting while being surrounded by curing resin. So that's 2 issues right away. So the result here is, what we realize is that, printing vertical, first off, may not be the most optimal strategy for this customer. We recommend to kind of bringing back the nesting orientation a couple degrees, and we recommend them printing about 75 degrees instead of 90. And what that 75 does is, instead of printing fully vertical, you're kind of printing this now on still a vertical angle, but it's more of a steep angle, so that everything here is able to successfully print on itself without the need of supports. And that's kind of important to remember. So takeaway here is that, make sure the designs of your splints are within recommended thicknesses. And, if you're going to have a highly dense vertical print, make sure you're checking the slices so that your that intaglio region is not failing due to an overhang. Or you don't have an issue here where you have a lot of printing, a high density print, and then you have a small pocket of liquid resin, and you're asking for this small pocket to not cure whatsoever. And I think that's where the biggest issue and difference between with this customer. And this one's probably a more common splint issue, which is very easy to rectify. So a lot of the issues you'd be coming right off the printer, you see half the splint print, half the splint won't print, or you see areas where it just randomly fails. Best thing you want to do at that point is first look at and inspect where it first fails. Everything's printing from the build plate up. So the layers on the build plate is going to be printed before the last layers. So I say that because you want to identify where that failure started. And then, yes, after that failure starts, it's going to propagate and be worse. So as you can see down here, over at the anterior, which in this case, this is a 2 splints printed at a 45-degree angle. The anterior was directed towards the build plate, which means the posteriors were up, and then everything was supported properly. What we saw was that the splint itself was too close to the build plate. If you are printing on supports, we recommend a minimum support height of about 3 to 4 millimeters. What you can see here is that this anterior of the splint was almost directly on the build plate. So there was not much room for the supports to fully print successfully. And that's really important. If you have supports that are too small, whether that's 1 millimeter thick, and I'm talking about in height, you're not giving enough room for new resin to flow in and replace the old resin that's being cured. That's one. Two is you want to check your support settings. As you can see here, I noted that there are multiple islands on this print. So like, again, what I said in the past slide, an island is a portion of the splint that's starting to print that's separate from the rest of the splint. So in order for that to successfully continue to build, it's better off to make sure that everything is supported and those islands are also supported. So to resolve that, we recommended them adjusting the support settings, both that contact width. So the contact width is the portion of the splint that's being in contact with the support. So if this width is not thick enough, that splint, when it starts to print, it's just going to rip right off. And then what you're going to get at the end of the print is just a beautiful print of splint supports, but no splint. And that is frustrating. So make sure you check your support contact widths. And again, I included all of those recommended supports on this slide. So if you didn't have that written down, definitely reach out. I'll be able to send those values to you. And then models. So models, we've seen some printing issues with our Key Model Ultra or Key Model and Ortho Model. And what we've been able to determine is also, hey, when there's limits being reached and being pushed, you're going to find some trade-offs. And one of those trade-offs is when you're printing high density model prints, you want to make sure there's enough room for proper dynamic resin flow. So as you could see on these prints, we were printing almost a full build plate of very solid, thick models with also a base layer. So they were printing a full base layer, printing the entire span of the printer as a base layer, which is now generating a lot of heat within the vat. And then now on top of that, let's print 4 very thick models. And what happened here is where the high density prints, the peel force of separating from the resin tray film is exceeding the bonding of each of the layers. So if that peel force is much, much higher, whether it's due to high density prints, whether it's due to underexposed resin, maybe your settings aren't fully validated and it's underexposed, or if there's not enough room for resin to be able to flow through hollow models, that's where you're going to have a peel force concern. And again, once the peel force exceeds the bonding of those layers, the inner layers from each other, that's when you're going to start seeing failures, delamination, and that's what's occurring here in these pictures. So these are issues that mainly may happen on some of these lower economical printers that we work with, where users are kind of making their own printing adjustment setting, like adjusting their own settings. But occasionally you'll see some of these issues on some of the large format printers, which then we have to go in and make some special adjustments to make sure that we can control both that peel force and the heat generation of the resin. So definitely take a look at these notes here. Reach out to us if you're if you need some assistance. All right. Can I use the same post-cure settings for another workflow? So this is a very important thing, because what we see a lot is users have a variety of printers. I mean, you yourself have more than one printer in the lab. And if you have printer A, printer B, printer A is validated with this curing unit, but printer B is not validated with this curing unit. Can we use it? And there's a lot of question marks around that question. And this is where I'm going to give you a little bit of context to why, as a resin manufacturer, we don't necessarily recommend that. So when it comes to the total energy that's being cured onto a device, we'll say a splint, so a KeySplint soft night guard. So it's going through printer A, and it's being validated with a specific printer energy dosage. Then it goes to be washed, and then now it's going to be post-cured with another set of post-cure energy dosage that we have validated here at Keystone. So as you can see, both of those energy dosages together is the total energy dosage that the KeyPrint product is receiving. Now, as an example, you can see that printers are different, all right? Like, as much as a lot of the printers, the output can be very similar nowadays with the technology advancements, but the printer guts are different. Different printers have different wavelengths, different intensity levels, and this is going to change the output of the product. And for example, here you could see how a resin like Key Guide on two different printers can be validated at two different energy dosages. So that's a really important thing to keep in mind is, all right, Key Guide is both validated on both printers, but what's the printing settings for those both printers and how different are they? So if now I'm asking if both of those printers can be post-cured, if Key Guide can be post-cured at the same curing time and curing unit from both printers, that's not necessarily the case, because one printer is receiving double the amount of energy that the other printer is as well. So this is where we recommend going to our website and making sure that you are working with a validated workflow. And if not, also reach out to our customer service to be able to provide some support. Again, remember the workflow. This is everything we're testing in our lab. So, you take a part of that workflow out, say the curing unit, say the printer. If you're changing parts of the workflow, we need to make sure that we're retesting that on our end so that we can provide those results to you, and that you're providing optimal devices for the end user as well. So keep in mind the workflow. Alrighty. How does improper post-wash affect your 3D device? We talked about a lot about the printing. We talked about it post-cure. We haven't really touched about the IFU for post-wash yet, but very easy. So as you could see here in the white is what Keystone publishes as our post-wash IFU. So what we try to do is, because we work with many different resins across different printers, platforms, then across different post-curing units, we want to make sure that the IFU wash using isopropyl alcohol is controlled as possible. We recommend 2 isopropyl alcohol baths, at least 97% purity. We recommend no more than 3 to 5 minutes of submerged IPA. So typically, clean IPA in bath 1, wash for 2 minutes, take them out, blow dry, make sure everything's blow dried in between, goes into bath 2, an additional 2 or 3 minutes, and then you can blow dry and then go into your dry stage. So that's typically what we would recommend. The equipment that can be used for your post-wash is pretty open. There's a lot of different companies that provide very similar units in the ultrasonic orbital shaker type of technology. And we also recommend using soft brushes or Q-tips to help remove any resin that could be trapped into some smaller areas. The biggest thing you want to make sure is not to overwash your products. Sometimes I go and I see that people are, washing surgical guides for 20 plus minutes. And what you're ultimately doing is allowing the surgical guide to first degrade because it's now absorbing all of this IPA. And then now, once you go and take that surgical device, you go and autoclave it, make sure it's sterilized, you go and post-cure it. Once it's done being autoclaved, it's going to come out looking like this on right here. And this is something that a lab reached out to me on, asking why, hey, I autoclaved my surgical guide and afterwards it's looking very flaky and it's completely cracked. What happened? And what we identified was that they were overwashing and they were not allowing enough time for all of that IPA to then evaporate. And then, so once all of this IPA is now absorbed and now becomes trapped, when you trap heat expands, and that's where the cracking and the flaking is coming. So if you're receiving this, or in general, just make sure that you are following Keystone's IFU for post-wash, and make sure that you are properly washing all of your devices. And then our last question here is going to be, is nitrogen necessary when post-curing? And, this is something that we get asked a lot. And one of the biggest aspects and takeaways from this slide is that we always recommend it. So anytime you're printing and post-curing with a medical device resin, we would always recommend using nitrogen or using vacuum. There's different curing units that provide a vacuum aspect, which is doing the same thing. It's removing the oxygen from the environment to inhibit a better cure onto the surface. So nitrogen isn't necessary, but it's recommended because, as you can see from these results with Keystone Soft across 2 different printers that were validated with, the use of nitrogen does help increase mechanical properties and help surface quality. So that's why it's highly recommended. When Keystone does all of our validation testing, we typically don't do nitrogen because we like to validate using a worst case scenario and to also show you and provide you that confidence that nitrogen isn't necessary, but it's always recommended for the proper and the best way to produce that end device. Alrighty, so we're near the end of this presentation, and let's talk about polishing our skills. So one of the biggest things, as Keystone's Keysprint Soft and Hard has become very popular, one of the next questions that come to us is, what's the best way to polish that? And lucky for you, Keystone has provided that for you. So on our website, you could see all of the technical information. We do have tutorials, a whole video on the polishing protocol, and then we also provide a key polish kit, which provides a little bit of each of the compounds and the entire IFU for properly polishing Keystone Soft or Keystone Hard, or really any of our KeyPrint medical device resins. So for more polishing information, you can check out our website. And again, that's where you'll be able to find both a tutorial video and the IFU. And then lastly, I know there's another poll question, so I'll let that be answered. But the biggest thing is, do you know what our website has in store for you? So we have a lot of information here at Keystone, and we do a lot of work with our validations, and we want to make sure that you're fully aware of how to find that on our website. So if you go to our Keystone website, you'll be able to see a KeyPrint section, and that's the section you would want to select if you want to go see everything about Keystone's KeyPrint products. You could also use some of our other sections here. You can view all the other 4,000 SKUs that we have and see what other products here at Keystone works best for your lab. Why not? So once you go into our website and you go under that KeyPrint section, you're going to see what I showed you earlier, all of the different printer partners that we work with. But if you see at the top, you can go and select the different resins, accessories, or compatible workflows. Or at the bottom, you can see that there's a button to see all the compatible printers in a PDF. And that's the PDF I showed early at the beginning of this presentation with all of the different printers and different resins that we have. And it shows you all of the different validations that's in progress, completed, or not planned yet. So that's a good guidance, kind of like a reference PDF to go to if you want to see what validations are completed. And there's always a date to show you how recent it is. And then you could also go see it right on our website here. And at the top, you can go to the compatible workflow section and then be able to choose which printer you're working with. So again, this compatible workflow section at the top, this dropdown will take you to an individual site for all the different printer partners we work with to show you what's all of the validation work we've done with that printer. For instance, here's the Asiga page. And as you could see, here's the 2 printers we worked with and have validated: Asiga Max, Asiga Pro 4K, fully validated across all of our materials here. And then if you scroll down, you'll see where the printer settings are. Some of these printers, we do provide the printing settings here on our website, but printer companies like Asiga, we make sure that you're aware of, hey, those settings can be found in the Asiga Composer and through the Asiga support website. And then lastly, compatible curing units. At the bottom of each of the printer pages, you could see all the different curing units we validated and tested with all of our materials. And this is a good way to see of all the different curing units we've tested, all the different printers we tested, and a great way to just reference to make sure you're using a fully validated workflow. So definitely reach out if you have any specific questions or concerns on information found on our website, and we can certainly help direct you to any more information that you'd like. And lastly, I believe this is my last slide, but you'd be able to follow me on LinkedIn, check out our Facebook page. We do have a KeyPrint Facebook page that we do like to help bring all of our customers into one spot. People can help ask questions, help resolve troubleshooting issues. And then you can also see the latest information released by the Keystone team. And also that last QR code, check out our website. That will take you to all the compatible workflows that I just showed you. And that would be a quick way to kind of always reference what Keystone's technical team is always up to and always be able to help provide any accurate information for you. So I want to say thank you very much for your time. Zahn, thank you for having me here. It's really exciting talking about 3D printing, if you haven't noticed. But we're always here as well, so reach out anytime you have any questions. And thank you very much for your time today.